All right, this next section is on translating word problems. This is always students' least favorite thing to do, but if you can really focus and work one problem at a time, they're really not that bad. So the first section for translating word problems is section 3.3 in your textbook on problem solving with one unknown. And before we get into the actual problems, we just want to practice working with these different common phrases that you're going to see a lot throughout these problems. So we're just going to focus on different expressions and translating them from English to math so that we can kind of see how they work. And we're going to use the letter X as the variable. So if you see the phrase a number plus 5, that should make you think of X plus 5. A number plus 5. You could write 5 plus X, and because it's addition, it's the same. So X plus 5 is the same thing as 5 plus X, only because it's addition. If you see the phrase the sum of 1 and a number, sum means addition, so the sum of 1 and a number, 1 plus X, or X plus 1. Again, with addition, it's okay to get them switched around. If you see 8 more than a number, 8 plus X, or X plus 8. We tend to prefer the variable first, but it doesn't matter. 8 plus X or X plus 8 for 8 more than a number. Negative 21 added to a number. Negative 21 added to a number, or X plus negative 21. Now that's the same thing as subtracting 21. So adding a negative, as we know now, adding negative 21 is really subtracting. And the last one, a number increased by 4. So a number increased by 4, or 4 plus the number X. Relatively straightforward for addition. Those are just some of the phrases that you'll see that indicate addition. More difficult are the phrases that indicate subtraction. Subtraction's a little trickier because order makes a big difference. So if you see 2 less than a number, the phrase less than means that the number has to go first. X minus 2. That's 2 less than a number. So when you see the phrase less than, you have to put whatever's second first, and then whatever you see first goes second. So the less than phrase is kind of tricky. But if you think if I had $2 less than my brother, I'd have to know how much my brother had first and then take away 2. So it has to be X minus 2. It cannot be 2 minus X. So order matters. Order matters for subtraction. You might want to make that side note. Order matters for subtraction. Order does not matter for addition, but order matters for subtraction. So again, here's another one. If we see a number subtracted from 9, the 9 goes first. 9 minus X. If we're subtracting from 9, we have to start with 9 and then take away the number. So again, if you see the word from, whatever's that after from goes first. Like if I'm driving to work from my house, I start at my house and then drive to work. So the phrase less than and the phrase from means you switch the way you see it. It cannot be the other way around. So subtraction is very specific. Here we have 9 subtracted from a number. So that would be X minus 9, not 9 minus x. So that word from means you put whatever second first. The phrase less than, you put whatever second first. The next phrase, a number decreased by 5, goes exactly how it shows. A number decreased by 5. Not the other way around. And if we have 7 minus a number, it's just exactly how it looks. 7 minus a number, not the other way around. So again, order matters for subtraction. And the two phrases that get switched around is when you see the phrase less than and when you see the word from. Those two key phrases tell you to switch the order, put whatever second first. And you'll get used to that as we see different examples. And then we have multiplication and division. That's pretty straightforward. 3 times a number, 3x. The product of 6 and a number, 6x. Double a number, double means 2. The quotient of -5 in a number. Now division, whatever you see first is what you put first. So -5 divided by a number. And order matters for division, so it's not the other way around. Order matters for division. Multiplication and addition, it doesn't matter. Division and subtraction, it matters. So this says a number divided by 8. You need to put the number first, and then divided by 8, which is x over 8. This one's a tricky phrase. I'm going to slow down here. 31 subtracted from 10 times a number. So 10 times a number goes together as one thing. 10 times a number. That's 10x. We see the keyword from, which means we put this first. So 10 times a number goes first, and then take away 31. You might want to put a star by that one. That's a very common expression that's easy to get switched around. But when you see the word from, you have to put whatever second first. And 10 times a number is one piece. And then finally, if you see the result is, that indicates an equal sign. So these are just some of the phrases you're going to see throughout these different word problems. They always use different phrases, and you just have to carefully work through them. The hardest part of this is the translating. That's why I call it translating word problems. It's translating from the written English to the appropriate math expression. That is where we have to take our time and set it up correctly. So I just have a few examples here. We'll work through these. And then the other section, 3.4, has some more difficult problems, and I'll record those in a separate video. Alright, so let's look at example 3. So I called this whole thing example 1 and this whole thing example 2. So at the very bottom is example 3. It says if 3 times a number is added to 14, the result is 38. This is a pretty straightforward translation. 3 times a number is added to 14. The result is 38. That is the most important part, translating from the written word to an algebraic equation or expression. That is what I'll be grading, translating from here to here. After that, finding the number is just a matter of solving the equation. And we've already taken a test on solving. So the solving part should be the easy part. It's the translating part that's really important. So from here we solve by subtracting 14. 3x equals 24. Divide both sides by 3. We should be very used to how to solve. And you get x equals 8. So the number is 8. But again, on your quizzes and tests, I'm really looking for getting the equation right. The solving part should be okay. It's the getting the equation right that I really want you to focus on. All right, let's look at the second page, examples 4, 5, and 6. If you would like to pause and try these on your own, you can solve these any way you want to. Some students can get through these without an equation. They can just kind of figure it out, and that's fine. I'm going to show you the algebraic way using an equation on how to solve this. But if you can get the right answer, whatever way you want it, technique you want to use, is fine with me. All right. So example 4 says, Allison had opened a checking account with money she received from her birthday. Yesterday she used her online checking account feature to pay her $62 water bill. Today she deposited $75 she received from a rebate. Now she has $237 in her account. And the question is, how much was in her checking account at the beginning? So the starting in her account we're going to call X. This is how I set this up. She starts with some amount of money that I don't know how much that is. That's how much she started with. If she paid a bill, she lost $62 from whatever that starting amount is. Then she deposited $75. And now she has $237 in her account. So this is how much she started with, which we don't know. She paid $62, got $75, and now she has $237. So this is the algebraic equation that you can set up. There are other ways to solve this, but I'm going to use this equation. So I'm going to combine like terms here. 75 minus 62 is 13. Positive 13, because how much she deposited is more than how much she paid, equals 237. And then I'm going to use my solving skills to subtract 13 from each side. $224. So she started with $224. And you can double check that. If you take the 224, subtract 62, and add 75, you should get 237. And again, I'm using an algebraic equation. If there's another way method you want to use to solve, that is fine with me. All right, let's look at example 5. Again, you can pause and try if you'd like. It says 5 co-workers each put in the same amount of money to buy their boss a gift. After they spent $4 for a card and spent $62 for a gift, they had $9 left. How much did each co-worker put in originally? So I see 5 co-workers, and they each indicates multiplication. They each put in the same amount of money. What they put in originally, that's the unknown. But there were 5 of them. So however much they put in, each, $5 each, $10 each, however much it was, times 5 is the amount of money they had to start with. Then they spent $4 and they spent $62. Now they have $9 left. So each person put in some money, times 5, because there was 5 coworkers. That's the total amount of money they had to start with. Then they spent $4, they spent $62, and now they have $9 left. So again, this is the algebraic equation that you can use to solve and answer the question. So I'm going to combine like terms here. That's 5x minus 66 equals 9. I'm going to add 66 to both sides. That's 5x equals 75. And then divide that amount by 5, because there was 5 coworkers that each put in some money. 75 divided by 5 is 15. So each coworker put in $15. And again, if you take that $15, multiply it by 5, because there was 5 coworkers, then subtract 4 and subtract 62, you should get 9 when you're done. So you can always double check your answers on these by plugging it back into the situation and making sure it works out. So each coworker put in $15. All right, and finally, this one's a little tricky too. Debbie has completed, this is a tricky phrase, 7 less than twice as many lab experiments as Sue. If Debbie has completed 9 experiments, how many experiments has Sue completed? So Debbie and Sue, I'm going to use D for Debbie and S for Sue. Instead of using X and Y, I don't want to get confused. So I'm going to use D for Debbie and S for Sue. So this phrase, 7 less than twice as many, that's a tricky phrase. The words less than means that we have to put that first. Twice as many as Sue. So twice as many as Sue is 2S. 7 less than that would be minus 7. And that equals Debbie's experiments. So let's read it again. Debbie has completed 7 less than twice as many lab experiments as Sue. So twice as many as Sue, take away the 7, should equal Debbie. The second sentence says that Debbie has completed 9 experiments. So 2S minus 7 equals 9 is the equation to use to solve. And then it's just a matter of solving. So add 7 to both sides. 2S equals 16, divide by 2, and S equals 8. So Sue has completed 8 experiments. So the tricky part again is translating from words to an equation. That is the part I'll be grading. The solving part should not be a problem. It's translating from English to math. And some of them can be very tricky, like this last one. So the more you practice, we'll practice in class, practice in your homework, the more you read these, the more comfortable you'll be translating the English to the math.